Okay, we definitely want to, get the long division, the really big one done. I'm just going to lay out the equation here, but what we're going to end up doing is moving on to the bigger area, the bigger bowl, and doing it there. Right now we've got somebody riding around with their BMX, so we can't go there yet. So we're just going to lay out the equation in the long division, not the long division form, but the fraction form. So you can take a look at it, and that's the long division we're going to end up doing, okay? If you notice, what we have is we got all the x's in descending order, but we're missing the x to the power of 1. So what we're going to do when we lay out the division statement is put in 0x to the power of 1, which is 0x, right? Just as a place marker, so when we're doing the doing the long division, we don't accidentally add unlike terms, and we know there's a missing term in there, okay? So keep this in mind, and we're going to take this and transform it into the long division form and take care of it then. So the question is, what are we going to multiply negative 3x squared by to give us negative 3x to the power of 5? Well, they both have negative 3 in front, so we don't need any coefficients up front. All we got to do is match the powers, right, the x's. So all we're going to do is multiply by x to the power of 3. Now, slight correction. Over here, it was supposed to be plus 5x, okay? So x cubed times negative x to the power of 2 is going to be negative x to the power of 5. X cubed times 5x is going to be positive 5x to the power of 4. And x cubed times 2 is going to be 2x cubed. Now, what we're going to do is change all the signs and add them. Negative 3x to the power of 5 plus x to the power 3x to the power of 5, they kill each other. 5x to the power of 4 minus 5x to the power of 4, these two end up killing each other. And 17x cubed minus 2x cubed is going to be 15x cubed. So the question we're going to be asking ourselves is, what are we going to multiply negative 3x squared by to give us 15x cubed, right? Because we're only concerned about matching the top numbers. What I ended up doing as well is bringing all these terms down, because I don't want to continuously look up, because every time I look up to try to bring something down, I might make a mistake. So every time I just transfer everything down, transfer everything down, transfer everything down. So what we're going to multiply negative 3x squared by to give us 15x cubed is going to be negative 5x, right? And that goes up top, and that multiplies everything out, and we're going to lay it all down here again. So what we're going to do now is change all the signs and add them. So 15x cubed minus 15x cubed, these guys are going to kill each other. Negative 31x squared plus 25x squared is going to be negative 6x squared. And that's just going to be positive 10x because it's 0x up top, right? 0x plus 10x is going to be 10x. And we're going to bring the 424 straight down, right? Because we're going to fill in everything. We're going to transfer everything down at the same time. So again, we're going to go back to the beginning. What are we going to multiply negative 3x squared by to give us negative 6x squared? That's just going to be 2, right? 2 times negative 3x squared is going to be negative 6x squared. And we're going to put the 2 up here, multiply it out with this guy, this guy, this guy, put everything down here, change all the signs, add them all together. So what do we got? We got negative 6x squared plus 6x squared. That's just going to kill each other. 10x minus 10x. Those guys are going to kill each other, right? And we've got 424 minus 4. That's just going to be 420, right? So we're left with 420. Now the power of this guy is less than the power of this guy. The power of this guy is just 420 times x to the power of 0, right? Now if this was 420x, you would stop as well because the power over here was less than the power over here, right? So right now, we finished our long division. We divided this guy into this guy, and the answer is that guy, that's the quotient, and our remainder is going to be 420. Okay. Now what are we going to do? We're going to move over and do a little division statement and write it out. We're also going to look at it graphically to see what it looks like graphically. Okay, it's just going to be a very simple graph, and you know, just a very basic graph of it, right? Now keep this in mind. We just divided this guy by this guy, so these two guys multiplied together plus that guy are going to be equal to that guy. But if we wanted to factor these further, we could factor this further. We could factor that further, right? Either using simple trinomial factoring, complex trinomial factoring, with a quadratic formula. So we could, and the top guy, the quotient here, is x to the power of 3. So we would actually use synthetic division to factor that guy, which we haven't talked about yet, but that's where we're going to, we're building up to, right? So what we're going to do right now is go to the other wall and write the division statement for this long division. And hopefully this made sense, because all it is keep this in mind. All you're doing is matching this guy with this guy, right? The first guy here has to match this guy here. Everything else works itself out. You get down to a place where the power of this guy is less than the power of the first guy in the denominator, then you're done, right? You've done your long division, and whatever ends up here is your remainder. Okay, so let's write the division statement for this guy, okay? So our division statement is our big polynomial, right? Our p of x, what we're calling p of x in division statement, is equal to the quotient times the divisor plus the remainder, right? P of x is equal to q of x times d of x plus r of x, right? Now, what does this mean? It means this polynomial is equal to this polynomial times this polynomial plus 420. This function is equal to this function times this function plus this function. Graphically, this is what it would look like. So graphically, this is what this expression, this division statement is actually saying. It's saying this function. It's actually, one thing to keep in mind with these graphs is they're not to scale. So this guy is actually going up all the way to 420. That one's actually 420, a line, horizontal line at y is equal to 420. And these guys are smaller scale. So the scales of the Cartesian coordinate systems on all these is not the same. It's just sort of a presentation of what it looks like, right? So the division statement up here, what it's saying graphically is this function is made up of, is equal to this function times this function plus this function. And when you're adding something, adding a function, it's just a translation. It's just moving around the Cartesian coordinate system, right? So if you multiplied this graph with this graph and moved everything 420 up, 420 higher, you would get this function, okay? And that's what the division statement is saying here, but we're saying it with terms, with letters, with numbers, instead of visually as graphically, right? That's what we did when we did the long division. The long division took our original function, we knew, or we didn't know, we just took this other function, whichever it was the negative 3x squared, the negative 3x squared. We took this function and divided it into here to see what would happen. You know, this function times what is equal to this? Well, this function times this guy plus the 420 is equal to this function, okay? I hope this makes sense, because this is really what we're getting at. Because polynomials and non-polynomials, basically functions in general, what we're doing is learning the different techniques to break things down and look at their core elements, and, you know, mess around with functions. Take a little function from here, take another function from here, combine them and see what happens. Take one function and take another function that we may like, we may want to, you know, that we've used somewhere, right? And, you know, it may represent something that we have, right? So taking one function and dividing it into another function just to see what the end result is. Is the end result what we want? Is the remainder what we want? Right? And keep in mind, this guy here is your y coordinate when your x's are these guys. Okay, so you can break these down even further, right? You can factor these down even further, get your x values, and if those x values you plug in to original function, this is what you get out. You get 420 out, right? So there's a lot here, and it's you know, it's just a graphical way of looking at it, and, you know, trying to, everything that you're doing when you're doing the long division, when you're doing synthetic division, when you're doing factoring, when you're looking functions, when you're looking polynomials, what you should be doing is thinking about this in a graphical form, right? Everything that you're touching, everything that you're working with, in general, is going to be a function, right? As long as we're dealing with polynomials and functions, right? Numbers, no. Numbers are just numbers. Basic operations are just basic operations. But those are building blocks, right? The real number set are building blocks. Variables are building blocks for us to be able to model things in real life and see how things work out. What happens when we combine functions together? What happens when we multiply functions together? What happens when we multiply functions together and translate them over, right? Move them around the Cartesian coordinate system. Do they give us what we want? Okay. This was the last long division that we're going to do, hopefully anyway. And what we're going to do from here is learn synthetic division and, you know, probably might even do this one using synthetic division. So once we finish synthetic division, we've done all the different factoring techniques that we're going to talk about for the polynomial sections, for functions, right? So we're going to have a whole arsenal of weapons. We're going to have a whole bunch of powers to be able to start going into polynomials, graphing polynomials, looking at functions, developing our own functions. Okay, and you know, stay tuned. We're going to go into synthetic division, and once we're done with that, again, you're going to look at synthetic division, and you're going to think it's super sweet, because it's a lot easier than polynomial long division, because you don't have to carry the x's over, and you can eliminate things much faster, and you can look at functions and actually look at the last term and look at the first term and guess as to the numbers that might actually go into your function that you're given, that you can factor properly, or they give you factors where your remainder is actually equal to 0, which means it crosses the x-axis. Okay, so next thing we're going to get into is synthetic division, and hopefully we would have left long division behind us a little bit. We might come back to this with other functions, but with other questions anyway. But synthetic division is what we're going to focus on. Okay, talk to you guys soon.